All right. So we are down to the last, actually, presentation of the Cisco Automation Developers Day. And, we leave for the last presentation, actually something extremely important and extremely, extremely cool that we see extremely often from customers. And I think we mentioned that when we saw the MPLS to SRv6. Migrations are some of the most common tasks that customers are taking. And the idea that, yes, automation can help, but now the question is, how can AI help me improving the time that it takes to do this migration? So I'm very happy to say hello to Sophia, to welcome you.
Hello.
And please take the stage to show us how can this happen.
I will try. Indeed, you cannot see anything because of the lights. Okay, so you are last of the last, and I am last of the last, apparently. So please bear with me. It will be quicker than you think, because also we have not that much time. But so I will skip some slides maybe, and we will go to the good part later on. To begin with, two truths. Either there are networks that they have been migrated, or there are networks that they are going to be migrated. During the whole developer days, we saw many times speaking about migrations of services, migration during, let's say, a software upgrade, a migration during a hardware upgrade. So this is why we set to go through this topic of pre- and post-checks using AI, in order to accelerate, let's say, the migration procedure. I know that this is, let's say, last minute, so you are not that much energized. So I will try to ask for your support. So please raise your hand, any of you that is planning to have, let's say, a network upgrade the upcoming 2 years. Okay, so good enough amount. And what type of network upgrades are you planning to do? If anyone wants to answer for that question. I saw some hands over there in the back that we are planning to do a migration. No? Okay. Here comes the Slido. So now you can interact indeed with the Slido. Thanks, Pradeep. So let's take 1 minute. Okay. Hardware upgrades, vendor change. I hope you're coming to Cisco. Software upgrades. Okay. So from here, we see that the majority is going to be software upgrades. And that's good, because the example that we are going to see later on, it's actually on a software upgrade. And one more question for you. Can we go to the next one? Okay. So here I will need the text from you. The question is actually, what is the most painful point that you have to undergo when you are having a migration procedure? Let's see. Rollback. Thank you, NSO, for the easy rollback. Tests that fail. Downtime and business impact. Service discovery. Planning. Thank you. Testing. Okay. Minimizing the impact. I would take that also part of the testing, maybe, and tests that are failing. Okay, so in our session today, we are going to go through the testing procedure and how we can use AI in order to enhance what we are going to test before and after the migration. And one other point that I see here that came is the legacy service configuration. This is something that we are also going to discuss during the session. Okay, so why are we going to do that, let's say, session, that demo. Why are we discussing about that? The upcoming years, the needs for migration, they are going to rise, either because this is coming with the new technologies, AI is putting us to the place, rather than changing the software that we are using, to change also the hardware that we are using. We need to go to more modern networks. When it comes to service providers, especially now with, let's say, the autonomous network levels, in order to jump from one level to the other, we have changes in the hardware, in the way that we are going towards the network. Also, the operational cost that now with the new technologies we can reduce is taking us towards, let's say, having more migrations. So the main categories that as Cisco we have seen is exactly the ones that you answered before: the hardware migration, software migration, services migration. And we are, let's say, separating it to different steps. The first step is to start with the planning, have the testing, discover, let's say, the topology, actually perform the migration, and lastly, go and have the post-check of the migration. So the reason that we start going through the procedure of pre- and post-checks using AI is actually to accelerate the top and the down layer. And further, since it is, let's say, a use case that you are able to use with a small modification in order to test your network in general. So when it comes to what we will see, we already saw the motivation. We will see the technology stack of that use case. We will see the challenges that I faced during building that one, a bit of the architecture, a demo, and if you have any questions. So when it comes to the technology stack, I will not stay here very long, because the majority of tools most probably you have seen in different presentations when you were studying on your own, maybe on AI and agents. So that we go further to the architecture. I always prefer to use some open source tools, and this is how this demo is built. And actually, after the session, I would like to fix some stuff that I faced, and then it will be open on the GitHub so that you can go there, test it on your own, and do any actions that you wish. So for me, in order to do that, it was very important to use open source tools so that any one of you that is going to use it and wants to play with it, they can just do it without having the need, let's say, to purchase any tokens. So from that table, actually what we are using, it's going to be the Streamlit, it's going to be a Llama model, the FICE database, and when it comes, let's say, to how we are building the agents, is going to be DSPy. So when it comes to DSPy is a framework that it comes for free. It is developed by the Stanford University. It is open source. It is quite easy to be used. You can take it. It's working in a declarative format. So a lot of things are happening on the background for you. You're providing the purpose and what you want the tool to succeed. And then the tool on the background is having all the necessary calls to succeed that. It is quite structured, so you will see later on in the code that, for example, when you're defining an agent, you need to provide the input, you need to provide the output, and on the background, the work is happening. It's quite modular and easy to be reused. And this way, it's simplifying a lot the procedures that you need to undergo in order to develop an agent. Further, let's say, especially in the customer experience organization, many people are producing agents now that we are in the AI magic era. So I prefer to use DSPy because also other colleagues are doing so, and it's always better to use, let's say, some unified procedure. Is it going to be the one that I will be using forever? Not sure, but for now it's working quite well with what I want to do. RAG, I am using RAG in order to make, let's say, the model smarter. We will see later on how we are using it in order to improve the accuracy. So I start seeing some challenges that we will go later on that one. And when it comes to architectural perspective, FICE database was the one that we are using because it is free. It's coming from Meta as Llama. So you can use it whenever you wish, just for free. Now, I had to choose an LLM. The main factors was for me to have something that you are able to take it back home and play without having to purchase any license or to have to go and, let's say, buy any tokens. To be big enough so that the context that it allows to take to be able, let's say, to consume it. and also to be quite fast and able to run on my local machine. My local machine, this poor laptop, had a really hard time the last weeks. I'm super happy that still works, at least for today. So I'm using Llama on that one. I'm using Llama so that you can take it back, you can work it at your own laptop, and actually, while I was working on that one, I started having different challenges, as I said, that we will see later on. So the model that I actually used was not Llama 3 itself, was Code Llama. As a graphical interface, I used Streamlit. It's quite easy to use. You take it, you build a graphical interface. It's always better to see something with some buttons, with providing some input. You can have it again locally or in a cloud deployment. And it's, as I said before, open source, so it has a community that is supporting it, and it's way easier for you to fix any issues that they might occur. So once more, we will go for a Slido. Thank you, Pradeep. So if you are having any, let's say, deployment when it comes to agents from your organization, if you are having any agentic framework that you are using, can you please share which one is that one? Is it LangChain? Is it, let's say, DSPy? Is it any other framework? LangChain? Yeah, so far it's the most famous, let's say. LangChain and Crew AI. Let's see, I have 2 more participants typing. Okay, LangChain, we have 1 more vote. Okay, so I think so far, and Crew AI, yes. So far we have Crew AI, that the majority, Pydantic, good one. I want to explore that one too. Okay, so let's say so far LangChain, Crew AI, Pydantic, they are winning. So I'm using DSPy, try it when you go back home. And we can go to the challenges. So we start very optimistic. Let's use AI in a different way. Why I say in a different way? Because so far what we have been doing is taking data, analyzing those data, and providing back some, let's say, outcomes. I wanted to do it in a different way around. So you provide, let's say, the migration, and then we are generating from zero those test cases, those scenarios, that code. So it's not about analyzing something that was already there. So as we start working on that, I started seeing many, let's say, issues. To begin with, the code that I was taking back was quite generic, as well as the test cases and the scenarios. It was hard for us to keep the documentation comprehensive. It was quite hard also to have the local setup with let's say, max 16 gigs of RAM without any GPU. I will, for sure, after the session here, I will move it to a bigger lab so that I am able to train it more, so that I am able to do, let's say, more advanced things. And of course, choosing the correct tooling. I was super eager to have everything running in the local machine so that it's something useful also for you to go back home and play. So that put me in a lot of, let's say, search when it comes to tooling that is able to cooperate with my machine. How did we overcome? How I overcame those, let's say, challenges? To begin with, I started realizing that being very generic, it means that a lot of information are missing, meaning that we need to put something extra. So when it comes to the planning, I used documentation coming from Cisco. When it comes to different software versions, when it comes to upgrade guides, in order to make, let's say, the model smarter. Same-wise for PyATS, you will see later on in the code, I am infusing different web URLs that are coming from developer.cisco.com, some repositories from GitHub to make it, let's say, more PyATS personalized. Same-wise for robot, because I try to make it working with both frameworks. I used first robot. Since Code Llama, for example, is already trained to work very good with Python, with robot was not providing the same results, so I turned back to the PyATS. So how it looks like. As I said before, we used different, let's say, documents and sources in order to train further and make smarter our local machine. We used for the test planner, device configuration, coming from cisco.com, device upgrade guides, some mob templates, and some test plan templates. When it comes to the test generator, I went through PyATS documentation, uploaded in the RAG, Python code examples, robot framework documentation, and robot examples. So going through the flow. So the idea is we have the user. The user is providing back to the first agent through the graphical interface, the migration type that they want to succeed, and the test bed. That agent one is going to create a plan. This plan will be propagated in two places. The first one is going to be the second agent that is going to take it and through that create the test cases, and is going to go back also to the graphical interface for the user to download it. Later on, agent 2, that is having, let's say, the test case scenarios, is going to provide back the code of PyATS to the graphical interface, and the user will also be able to download both the test plan and the test code. Later, the user is able to push another button and execute those test cases towards the devices. And then another agent, but in our case, it's either LLM, either agent. I went with LLM. Is having the test results, is analyzing, and is providing recommendations on how to check what is not working, what is working, and how to fix it. And that is going also to be downloadable, let's say, from the graphical interface. So this is how the whole architecture looks like. We are starting from the user. Then the user is interacting with Streamlit. The DSPy is doing actually the communication and the building of the agents. So agent 1 is going to interact with the RAG that it's having inside the documentation of Cisco and provide back the test plan. Agent 1 is going also to provide the input to agent 2. Agent 2 is going to communicate with RAG. RAG is going to give enhanced information about the code. Then that is going to be executed to the device. And finally, as I said, an agent 3 or an LLM is going to provide back to Streamlit the outcomes of let's say, the testing. So you see here, this is how the plan generator is going to look like. I don't think that the laser works, yes, but it's okay. So the generate migration test plan, as you see at the beginning, there is the word signature. This is coming from DSPy. So the first thing that you need to do is actually to provide an input and an output. So as an input, we are providing, let's say, details of the network migration, and as an output, a step-by-step migration test plan. As you see here, it's a quite detailed planning that is going to be used as templating for the agent to understand and provide the extra information. Same here for, let's say, the generate PyATS tests. We are providing a signature, and later on, we are providing exactly what will be the test cases and what will be the steps if you were a network engineer that you are going to run. And before going to the demo, one more question for you. So let's say AI now it's going towards places. We can do many things, and we can support in different manners your needs, and when it comes especially to the migration procedure. So let's say if you were about to get helped by AI in any step of your migration procedure, what would be that part that you would like to be helped? Something is broken, but it's okay. Okay, now it's coming. So it's pre and post checks, impact analysis, failure scenarios. Actually, your input is quite important so that we can support more and we build more use cases. Investigating errors. Rollbacks automatic, okay. Rollback. Okay. Provide general guidelines and possible mistakes. Pre-checks. Reassuring me pre and post checks. Okay. Thank you all for going through that. It's important for us. So I will start now with the demo because anyhow we will go back to the presentation. We will need 2 minutes to have the first results, and then we will go back to it. If you can connect me. Guys, if you can connect the laptop to the monitor, please. That one?
Is it something? Did it work?
No. Let's see now. Now it came here, but it's not here. Okay. So let's go here. So we will see the code later on. I will start with running the application. So in order to run it, I have already the model running, up and running. And I run it from here with the keyword streamlit run and then the application name. So when we run that, this is the page that is dropping us, okay? So let's say that I have typed it already. Let me refresh it if it's stuck. Yes. Okay. So let's say that I am the user and I want to go and have a migration. I first provide the migration information. Let's say, let me make it a bit bigger for you. Migration from, let's say 70.2 to 18.1 for iOS XE. Okay? Later on, you are going here. You need to provide your inventory file. Okay? And then we will start with generating the test plan, the test cases, and the job file. This will take 2 minutes approximately because it's running locally. So I will go back to the code in the meantime. So in the meantime, I will start with the RAG. As I said before, RAG is working in this following way. So we are having some web URLs that we are taking information from them. I am changing from HTML to actually a text. So here I'm loading, let's say, those URL files, and then I am having to build an index. So the idea is that we cannot work from an HTML perspective or from a text perspective because the LLM is not understanding that. So actually, when we are infusing things using RAG, what we need to do is actually to transform them from being a text, being an HTML, into being in a token manner. So, and this is what we are doing here. After that index is built, and we are building it, as I said before, in a FICE perspective, because it's open source, what we need to do in order to call RAG is to have the query items. So now, if I go and I query exactly directly that, let's say, database, because after all, it is a database, but made out of tokens, what will give me back is all the information inside the database that they refer to the same keywords with the ones that I have provided to. So later on, the other thing we need to build is, let's say, programmatical way to interact with RAG and our agent. And this is what we are doing here through the FICE vector store. As I said before, we are having an agent that is called a plan agent, let's say. The details that is having is the migration details. Here, if you go a bit more down, we are providing, let's say, dynamically the different types of the migration that the agent can perform. And lastly, when this agent is done, it's going to have the test plan as an input to the test case agent that is going to be, let's say, the agent to provide the PyATS test cases. And all that comes together in the application, let's say, file. So in that application file, we are formatting the output, we are building the application how you saw it before, and we start calling things. Here in the utils, you can see the RAG PyATS and all the necessary files in order to load, let's say, files, to open the URLs, etc. Let's see if it's already done. Not yet. OK, so now it's done. First thing, you see the generated test plan. You have, let's say, step 1 that is providing you to test the connectivity, ping the device, for example, check the hardware inventory, show the current version of your inventory, software version check is what is the version of the current software that you are running, what is the status of different services that you are having. And lastly, let's say configuration backup. This is something important because many of you said rollback. We are always checking that the configuration backup is there. Later, before that, we have the whole readiness assessment towards all the devices. Those will be run in order to be sure that all the devices are reachable. And then, based on that, we are having the generated test script that is using PyATS, hardware inventory, how to test it, let's say how to test the reachability, the service status, what will be the output, and the generated job file. So in order to run PyATS, you need a job file, and the test cases are going actually to be run through the job file, calling the PyATS. So from here, you can either download it, or the test bed, or the script, or the test plan in the Markdown language, and you can execute the tests. Now, I will execute it, but I have opened here from the previous execution that I did so that we do not miss time. So you execute. I have here simulated data, of course, for the service status, for the software version, the CPU. Now, what will happen? It will tell you what issues were found for the pre-checks, same-wise for the post-checks, and I will show you in the other window. It will give you also, let's say, recommendation actions of how to overcome those things. So this is, I ran it before the session so that we do not lose time. So let's say that device 2 is facing issues with the wrong software version, the current version that we were expecting. So it will provide you information such as wrong software version was detected, this, what does that error mean, how to test it, how it will look like inside the device, how to upgrade to the software version that you want it to be, and some additional tips. Same-wise, let's say CPU overloaded, it will provide you with some, let's say, useful insights on how to check what is happening on the background. And this is the application. Overall, how it looks so far. We have some enhancements that we are planning to do. Can we go, please, back to the presentation so that we can close it up? I can go if you wish. I have it open. Okay, I can go. It is there. Okay. So some future enhancements. What you saw is actually, let's say, try from our side to experiment a bit with migration, to experiment a bit with different frameworks, with different incoming information, and see if we can have something meaningful from the perspective of the architecture and what we are trying to succeed. In some aspects, it's giving me already, let's say, the results that I'm expecting. But in some other aspects, I need to change things. For example, I would love to experiment with different models for the different tasks, because I started running them on their own, and I saw that it makes a difference. We want to experiment with automatic topology discovery. And the other thing that we are planning after this use case is to experiment with, let's say, the configuration discovery, to understand whether the configuration is having any errors from what we expected and actually being able to change it. And that was it from my side for now.
All right. Thank you, Sophia. It was really, really good. And actually, in a way, for the last presentation, it brought together a lot of things we learned this couple of days here. The agents and the power of agents. I remember the code presentation when they talk about 3 use cases, about 16,000 test cases. Correct. So automating also testing, that I think people many times forget that that's a key part of what we do in network automation. And migration, correct?
It's a time saver.
It's a time saving. And, you ask your operation what they're doing, a lot of time migration. So do we have any questions from the audience? So I always have a lot of questions. So let me ask you something. Have you tested this in an actual migration? Where are you in the process? Is it still work in progress? It's part of your migration delivery?
I have tested it in CML devices in the DevNet sandbox. So far, it's giving us quite good, let's say, outcomes for the states that it is. So this brings us more, this makes us more optimistic for the future that with the enhancements that we are planning, it's going to work quite well.
All right. And remember, for those online, you always migrate from whatever you have to Cisco, correct? That's the rule. Okay, so thank you, Sophia.
Thank you,
Thank
guys.
you. Thank you very much.